Okay, so I think it's okay. So this is an exact equation, and with exact equations, you do, in order to check to see the exactness, you're going to do partial derivatives. Del m over del x, and then we just take the derivative. This is going to be 0, and we just take in this derivative, so it's 4x. Wait, is that right? Sorry, this doesn't have a y right here. But it does have the y right here. But anyway, this is 4x. And now we'll do del n over del y, which this is 0. But here, because this is a constant term, this is going to go away. So this is going to be 4x. And these are equal. And I don't know if I would use the identity symbol. I guess why not? I mean, they're the same. I did get dinged a lot on notation, and that's still something I'm learning about. So I don't know if that's correct or not. So now we want to find a function f of x, y, because these are the same. And what we're going to do is we're going to integrate one of these functions. So in this example, I'm going to integrate this one. So integrate 4x y plus 2x dx. Whoops. And that's just, very simple. The integral of 4xy is just, and this is with respect to x, so it's 4x, so that's 2x squared, y plus x squared, plus some constant, which, the constant we can call g of y, okay? So now what we're going to do is we're going to differentiate this with respect to y, and we're going to find that that's 2x squared plus g prime of y. Okay, great. Now I'm going to clear the board, mostly. Erase that part. I'll keep the original equation on there, just so we know what I'm referring to. I was going to do a different color. Let's do green. I don't know where I put my red marker. So we have 2x squared plus g prime of y. And now we're going to set it equal to this one, 2x squared plus 4y. And you can see that this and that cancel, so we have g prime of y is equal to 4y. And we just integrate, and now we get g of y is equal to 2y squared. And then we can just combine these. So 2x squared plus 2y squared. Is that right? I have these notes right here. So f of xy is x squared plus 2y squared plus 2xy squared. No, 2x squared y squared. I feel like I'm missing something. 2x squared plus 4y. G prime, no, okay, so g of y is 2y squared. So f of xy, x squared plus 2y squared plus 2y x squared. 2y x squared. And this is equal to a constant, a level curve. Something about this is bothering me. I'm just going to start over real quick. 2x plus 4y, 2x squared dy plus 4xy plus 2x dx equal to 0. This is m, this is n. I already verified the exactness. I'm not going to do that again. And then I was going to integrate 4xy plus 2x dx equal to 0. Well, I don't really need to set that equal to 0 right now. So that gives us 2x squared y plus x squared plus the constant, which we're going to call g of y. Then we're going to differentiate this with respect to y. So we get 2x squared plus g prime of y. And then we're setting that equal to m, 2x squared plus 4y. And then we got g prime of y is equal to 4y. So that means g of y, after integrating both of these sides, is going to be equal to 2y squared. Okay, so then we get 2x squared y plus x squared plus 2y squared. Okay, and then that's going to be equal to c. And in order for us to solve this, we're going to, solve for y. And I did get a little tripped up on this. I'm sorry. I got a little confused. So I'm going to rewrite this up here. 2x squared y plus x squared plus 2y squared is equal to c. And this is pretty cool. So now, in order to solve this, we're going to divide everything out by 2. So we get y squared plus x squared y. And we're going to rearrange this to be kind of like a quadratic, plus x squared over 2 is equal to c. And we're going to isolate the y's. C. Oh, we could do c over 2. It's still c, but it's a constant, but we're dividing by 2. Still a constant, but either way. So now x squared over 2, and then with this term, now we're going to do y squared plus x squared y. I kind of messed up the order, but whatever. And then we're going to do x to the 4th over 4. It's b squared over 2. So this is the b part, is equal to c over 2 minus x squared over 2 plus x to the 4th over 4. And then we're just going to put y plus x squared over 2, quantity squared, equal to x to the 4th over 4 minus x squared over 2 plus c over 2. Take the square root, take the square root. So we get y is equal to the positive or negative square root of x to the 4th over 4 minus x squared over 2 plus c over 2 minus x squared over 2. And that's the function of that, what we're looking for. That's going to, give us this del m del x, our differential equation. And that's really how you solve them. And it's pretty straightforward, but sometimes it's a little confusing. I'm going to show you a trick. So let me rewrite the original problem. So we have 2x squared y dy plus 4xy plus 2x dx equal to 0. So the trick is, after you verify that it is indeed an exact equation, what you're going to do is you're just going to integrate both equations at the same time. Yeah, so okay. I just wanted to make sure I was... Okay, so you integrate both of those at the exact same time. So 2x squared, this isn't 2x squared, plus 4y, and 4x squared plus 2, okay, I got it right now. 2x squared plus 4y dy. This gives us 2x squared y plus 2y squared plus some constant that, you know, and that's the m part. And then the n part is 4xy plus 2x dx. And that's equal to 2x squared y plus x squared. Notice how we have the same term in there. So what we're going to do is that's going to be put in there, and then we're going to put in these separate terms in there. 2y squared plus x squared, and then you can set that equal to c or whatever, and now you don't have to find some function, integrate one side, and then you take the derivative, and then you set it equal, and you could just do this. I found that it works for the most part. Anyway, that's my video. Next week, or maybe not next week, I don't know, whenever I get around to it, the next subject that I'm going to be covering is when an equation isn't quite exact, but you can make it exact by multiplying by a certain integrating factor. Those are a little confusing at first, but once you get the hang of it, they're really not that bad. But yeah, thanks for watching. Yeah, I kind of struggled with these, but they're not too bad. Anyway, take care.